Hi, welcome to my video on graphing inequalities pertaining to the absolute value. Graphing inequalities. The steps that I'd follow, is I'll find the vertex and I'll plot it. I'll find the slope and I'll graph from the vertex going up if A is positive, going down if A is negative, and then I'll graph both sides. And when I graph both sides, one side will be positive, one side will be negative, or vice versa. And then I'll do the boundary line is solid if you got a greater than equal to or less than equal to. Solid is when you have an equal to. And dotted if you have no equal to, even though it's less than and greater than. The boundary line is solid if it's equal to, because all the points that are on the boundary line fit the inequality. And we shade above if we got greater than, equal to, or greater than. Above is going up, and we shade below if we have less than, equal to, or less than. And to verify that, I'll do a point. I'll find a point to verify if my shading is right. Okay, let's do some examples. Graph y is greater than 2 times the absolute value of x minus 1 minus 3. So I'm going to graph it using the vertex. The vertex, this is very similar to doing a parabola. Only difference is an absolute value is v-shaped, a parabola is a looping curve. The vertex is opposite of negative 1 is 1 and negative 3. The a, which is the slope, the a is 2, so that means the slope is 2 over 1. So let's plot the vertex of 1, negative 3. 1, negative 3, negative 1, negative 2, negative 3. And the slope is 2 over 1, so we'll rise 2, run 1. We'll rise 2 and run 1 to the right. Also, that's the positive side. Now we'll rise 2 and go 1 left. We'll rise 2 and go another 1 left. So that gives us now I got to be careful. I got the vertex plotted. The boundary line is greater than, there's no equal sign, so that means the boundary line is broken. So I will start at the vertex and draw the boundary line broken. Go on one side and then I'll go the other. So the boundary line is not solid, it's dashed, indicating that the boundary line is not a part of the graph. Greater than is above, so that means I'll shade above is this way, and less than would be down this way. So above would be going up like this. So shade all points. So that's the graph that represented. And to test it, I'll test the point 0, 0. So let's take the point 0, 0 and test it. So 0 for y is greater than 2, absolute value of 0 minus 1 minus 3. So 0 is greater than the absolute value of 0 subtract 1 is negative 1. The absolute value of negative 1 is 1. And so 0 is greater than 2 minus 3. 0 is greater than negative 1. That's true. So this point fits. So that's shading inside. Shading in above here, not down here. So if you picked any point out here, it would not satisfy the inequality. So any point that's, again, this goes on and on and on. So any point here satisfies the inequality. Okay, let's do another one. We have y is less than or equal to the negative absolute value of x plus 2 plus 1. And the vertex is the opposite of plus 2, which is a minus 2, and 1. Remember, when you put a negative 2 in this expression, you get a 0. That makes y 1. So a is, that's a negative, so it's a negative 1 understood. so the slope is -1/1. So let's plot the vertex of -2, 1, right there. So we'll go down 1, right 1, down 1, right 1, or we'll go down 1, left 1, down 1, left 1. Now I'm ready to draw the V shape from that vertex, and we have an equal to, so that means the boundary line is solid. So here's one side, and that side is the positive, oops, I'll put an arrow there, that's the vertex, and this side is the negative slope. So there it is, and less than, again, less than is below, so there's the V shape, so I shade down. So there it is. And again, the test point I'm going to use is 0, 0. If I can use the 0, 0, it's the best one to use because it's the easiest number to plug in. That's the test point. So 0 is less than or equal to the negative absolute value of 0 plus 2 absolute value, and 0 is less than or equal to, and 0 plus 2 is 2, the absolute value of 2 is 2, plus 1, 0 is less than, notice, -1, and that's a no. So this point, this is not true, no, so we can't shade out here because it's not true, so we must be shading in here. Okay, let's practice means pause the video and see if you can graph these correctly on a sheet of graph paper, and then press playback to see if you're right. The vertex of this parabola is x is 0 because there's no number inside. When I put a 0 in here, y is -2. The a, or the slope, is a half. So the vertex is 0, -2. X is 0, -2 right here. And the slope is a half. So that's rise 1, run 2. You rise 1 and you run 2. And we go the other way. You rise 1 and you go left 2. You rise 1 from here and you go left 2. And notice this is the positive slope because it's up to the right. And this is the negative slope. It's up to the left. So let's, and the boundary line, there's no equal sign. So the boundary line is broken. So we do a broken line. And we do a broken on this side. Okay, line it up. Okay. And less than would be below the line. Greater than would be up here. Less than is down here. So these are all the points here. So that's, and again, 0, 0 is my test point. 0, 0 should make it not true. So it should be not true. So 0 is less than a half. Absolute value of 0 minus 2. 0 is less than a half. Absolute value of 0 is 0 minus 2. 0 is less than 0 minus 2. 0 is less than -2. No, not true. So we can't, that's 0, 0 is not a point that fits this, so we can't shade, so we shade it in the right area. So always test to make sure. And number 2, graph. Again, we have an absolute value. The vertex is opposite of -2 is 2. And we have -2 gives me a 2, so it's a 2, 4 vertex. A is -3, which is understood to be -3/1. So plot the vertex of 2, 4. X is 2, y is 4, 1, 2, 3, 4. And we have the vertex done, and we go down 3, 1, 2, 3, right 1. Down 3, 1, 2, 3, right 1. And when we do this on the other side, we go down 3, left 1. Down 3, left 1. Okay. And this is equal to, so the boundary line is solid. That means the points on the lines are included in as part of the solution. So this is a solid because of the equal sign. The points on this line are included in the solution. So there it is. And greater than is above. So these are the points, all these points, the points that are on the boundary line and all points that are above this V shape. So all these points up here, any one of these will satisfy this inequality. That means if I'm going to take the point again, 0, 0, and notice that 0, 0 is in my solution, so it should make this inequality true. So 0 is greater than or equal to negative 3, 0 minus 2 plus 4. So I'm subbing 0 in for y and 0 in for x. 0 is greater than or equal to negative 3. That's a negative 2. Absolute value is 2. 0 is greater than or equal to negative 6 plus 4. 0 is greater than or equal to negative 2. That's true, so we're shaded above. Perfect. And number 3, graph this absolute value, the vertex. X opposite of plus 1 is a minus 1, and there's no number out here, so that's understood to be 0. The A, which is the slope, is 2 over 3. So we plot the vertex of x is negative 1, y is 0, right there. And we go up 2, right 3, 1, 2, 3. Up 2, 1, 2, and we go right 3, 1, 2, 3, roughly right there. And now we go up 2 to the left 3, 1, 2, 3. And we go up 2 and to the left 3, 1, 2, and this is just an approximation. So now our boundary line that we had to put in is a greater than, but there's no equal sign. So again, the boundary line is broken. It's not solid. That means the points that are on these lines do not make the inequality true. And we line these up, and if I have, okay, there it is. And again, it's broken. Oop, big line there. And greater than is above. So that means all the points that are up here, all the points that are above these rays make this true. That means 0, 0 is not in there. So that means the point 0, 0. Now, if you do not have the point 0, 0, and if the graph passes through the point 0, 0, then pick another point with a 0 on it. Pick this one 3, 0, or pick this one down here, or wherever you want. But this point is not going to be true. So y is 0 greater than 2/3. Absolute value is 0 plus 1. 0 greater than 2/3. And that's a 1. Absolute value of 1 is 1. 0 is greater than 2/3. And that's no. So this point is not true. So I shaded in the right area. Perfect. Remember, you pause the video and work it up beforehand, and then see if you're doing it right. Now, this one's a little bit different. It says solve the system. Now, notice that this is a system of two inequalities, but notice that this one right here is a linear. This one is y equals mx plus b. Even though I'm putting equals here, that I know that's a less than, but this is the equation of a line, which has, this line has, if you look at with an equal sign, it has a slope of a negative 1/3, and it has a y-intercept of 1. Y equals mx plus b. So let's graph this inequality. This is linear. Notice that this is an absolute value. This is the one that's going to have the V shape, but this one is just going to be a line shaded one side or the other. So let's plot the y-intercept of 1 right here. And the slope is down -1/3. So we go rise, we go down 1, right 3. Down 1, right 3. So let's say that that's the line. And we plot that line roughly right there. Okay, here we go. Now, notice it's no equal sign, so that means the boundary line is broken. So this is a line it's linear. And also, to remind you, if you want to look over all the systems, in Algebra 1 on my YouTube channel, Algebra 1 has the linear inequalities with a single variable, and the Algebra 2 has 2 sets of inequalities, has a linear inequality with 2 variables, and has a quadratic inequalities, and quadratics have 2 variables. So there's many units that I have done stressing the inequalities, graphing inequalities and solving them, etc., etc. Now let's graph this absolute value. The vertex of this absolute value, the opposite of -1 is 1. The opposite of -4 is, opposite of -1 is 1, and you got to keep the -4. But before I do that, I forgot. I did the line, I did the boundary line, but I forgot to do the shading. And again, this is a less than, and a less than is below. So let's shade down here. So there's the shading. But in order to, excuse my arm for a second, let's graph the absolute value with a red pen, so we can see which one, where the overlapping is occurring. And the A, which is my slope, is 2, which is 2/1. So let's plot the vertex of 1, x is 1, y is -4. 1, 2, 3, 4. And the slope is 2/1, so it's up 2, right 1, up 2, right 1. And now I'm going to go up 2, left 1, up 2, left 1. So I'm going to draw the V shape, the absolute value of the V shape, and the boundary line is broken again. The boundary line is broken. So I'll do a dot. Okay, there's one side. And remember, this is like a parabola. I'm trying to get just off here on my line a little bit. As you can see, I'm off a little tiny bit. I'm plotting it, but what happens is this point should be over here a little tiny bit, and it should go through here. Okay, just off a little tiny bit. It should go through this point right here. Now, this is why I did one in black and one in red, and this is a greater than is above, so we shade up here. Notice the boundary lines of both of these are not included, but the system is really, allow me to use a different color if I can find a different color here. Let's see, yeah, okay, I got a different color. What happens is that because they're inequalities, we can't get 1 point or 2 points or setback. We have many, many points. So we're below this line. So these points are not included in the overlapping. These points here are not included. So the solution is where the red lines and the black line intersect. So the solution is the interior. So let's call this an A, and let's call this V for vertex, and let's call this a B. These are the points of intersection of the line A and B. The line intersects the absolute value graph, the V-shape. So the solution is all the points that's inside of this triangle. Any point that's inside the triangle will make both inequalities true. Any point that's inside the triangle. So the solution is the interior of the triangle AVB. All points inside the triangle. So take any point that's in here, and any point that you pick in here, no matter what point it is, you can pick the point, any point. But whatever point you pick, it will make both of these true. It'll make the linear inequality true, and it'll make the absolute value inequality true. So I might end on that note, having a notice, again, this is an absolute value, V-shape, and this is a line, but shaded below. Again, below, less than is always be downward, and greater than is always above. And if you like my video, click on the like button, the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content is on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.